Thank you for giving me the opportunity to say something about something that we set up for curation of the content that we have on WikiPathways. In some of the previous talks, we actually saw alternative approaches, including the previous talk, where owl reasoning is being used to identify potential issues. And this presentation will be basically about the same thing, technologically a slightly different approach, maybe a bit more flexible. We could do owl reasoning. That is one thing that we do not do there. But I will say something about that. So automated curation of internal and external validation. So that's where that flexibility comes in. We're not just looking for internal validation, which we'll see actually in this case do not necessarily make sense. I'll explain in a moment why. But also by comparing content that we have in WikiPathways with content from other databases, so towards interoperability of the pathway content with other databases. So some of the things that I was interested in when I joined the WikiPathways team in Maastricht in 2012 was the metabolic pathways, and there was a lot of work, a lot of curation work possible there. Were a lot of things that we'll see that are not being tested at this moment. So a lot of metabolites at that time were not annotated with identifiers at all. They were very often not even identified as a data node, so we could not map experimental data on it. They were just labels. And so there were a number of things that over the time I ran into, and at some point I started collecting those things, starting integrating and automating that in a computer-assisted curation workflow. So the kind of things that we why would we want to do that? Well, I do not really have to introduce it because that was mentioned by the other speakers as well. It's just really helpful. We make mistakes, we have inconsistencies. Pathways do not always are exactly clear what is meant. Some of those things you can actually recognize. So some of the things that we see in pathways, the second bit, that's by visual inspection are not always hard to identify. So for example, cache registry numbers used in pathways that are actually registry numbers for salts, where in the biological pathway it's actually one of the two components of the salt, which is doing the biologically interesting bit. Those you will not see if you look at the pathway. You see just one data node. Other things, something that we were discussing over the coffee break, was a wrong identifier for zinc ions, where in pathways we actually have an identifier for the neutral zinc element rather than the zinc ion. Now, and Denise in her first presentation gave a number of other reasons, things that we want to curate, like metabolites with undefined stereochemistry. Not necessarily wrong, but it might make the interoperability harder. Another thing that I would like to mention there is outdated and replaced identifiers, something that we repeatedly run into. External databases that we link to, they get updated, and so Cabby is an example of that. So they deprecate records every now and then. HMDB, same thing, and so assuming that everyone who wants to map experimental data onto WikiPathways that they are using the most recent identifiers, well, at least we want to make sure that knowledge, that data maps to it. Now, BridgeDB overcomes that to some extent. But we like to have the latest identifiers, so we can test for that. So that's one example where external data comes in these tests. We can see which older Cabby and older HMDB identifiers are used, and in a curation event update those to the most accurate identifiers. Now, secondary identifiers is probably not the biggest problem, the really deprecated identifiers, because the database content was unclear, so they really removed that identifier. Those are more important. But yeah, so over the time I saw a lot of other different problems, typos, for example, of very many kind of forms, and we want to not have to manually curate that all the time, but actually run this repetitively, and that is where this automated curation testing comes in. And you can see here by these numbers, so these are actually the counts. So these tests have been running for more than 5,000 times on the SPARQL endpoint. The next 3 jobs actually, they are run every time RDF gets generated for the pathway. So one of the output formats, which I will say a bit more about in my presentation tomorrow, and the resource description format. That RDF gets generated a couple of times a day, and after each time it gets generated, these tests are run again. So a few times per day we get new curation results, and that is nice. So each time something shows up that a mistake was made by a curator, it will immediately show up. It will actually go to our curator Slack channel, a messaging platform that the curators use. So we have very prompt way of reacting on that. Now, we'll see that direct correcting of things is not always easy, and so at this moment, which way I'm going? We'll see in a moment that we have a few failing tests at this moment for 1 week, 2 weeks now already, and they're not trivial to fix actually. So that's actually a discussion point that I will mention at a later moment. So we have a collection of about 60 tests that we run on the pathways more than once a day. And these are the kind of things, so the next few slides show some of the things that we're testing. So for example, we can detect gene identifiers from Ensemble at least easily if they're using the wrong species, the identifier for the wrong species for the given pathway. So human genes in mouse pathways or the other way around. That actually happens quite a lot. It's also not that hard to fix. So not very nice curation events that can be picked up by the curation team. MicroRNAs, that's one of the things that we'll see in a moment. So we have at this moment human microRNA identifiers in mouse pathways, probably the result of an homology conversion process, and it needs to be looked at. Another thing, NCBI gene identifiers in the pathways. Well, NCBI genes identifiers, they're integers. They were not always very easy to detect with a simple test. KB identifiers, we heard some issues earlier about formatted of that, but obviously most genes should not be identified with a KB identifier in the first place. Typo-like errors in these pathways, accidental things that visually looking at those pathways are not easy to see, but very easy to detect by this kind of approach. And here too, outdated ensemble identifiers, and we'll see that in a moment. So what do we do for metabolites? Well, the secondary identifiers are already mentioned. ChemSpider identifiers should be integers. If not, then yeah, there is something wrong there. It needs to be looked at. Things that have a metabolite identifier but are not marked as a metabolite. If they're not marked as any type at all, it's not that bad. But things marked with a metabolite identifier should not be a gene data type. Things easy to detect by these kind of tests, but not by visually looking at the pathway diagrams. So a few more also here, typos or misassigned data sources. So for example, compound identifiers, we know that those start with a C. So if the identifier doesn't actually start with a C, then either the identifier is wrong or the data source is wrong, things that we can test. And because this is run each time, so at almost the same time, someone makes a small mistake like that, the curation team can jump in. It's not integrated with the website, so you will not see these things at this moment immediately after you made an edit, but that is something that would actually be interesting, but technically at this moment is not possible. Interactions, that's also interesting. So yeah, there's a lot of curation that needs to be done there, typing of interactions, directionality of interactions, but once there is a bit of information there, we can do the kind of OWL reasoning things. So if we have an interaction and conversion, an annotation of an interaction between two genes, for example, it cannot be a conversion. One gene cannot convert to another gene. It can do have a lot of different interaction types, but one gene doesn't convert into another gene. Not the whole gene. A mutation, perhaps, yes, but not a whole gene. So those yeah, and that actually had a lot. It's also a typo-like thing, mistyped interaction type. Okay, good. Outdated data sources, so that is the problem that, yeah, so WikiPathways exists for 10 years now, things evolve, things change. Robin also mentioned that for Reactome, the platforms there are changes, and the pathways need to be updated for that. So data sources have been renamed, ChemSpider with or without a capital S. At some point, we had, for each species, we had a data source, a species-specific data source. That at some point got to change to the convention of always just using Ensemble as a data source. Those kind of maintenance things are also easy to detect. And then you get a nice overview of what needs to be done. So how does it work? This is more technical. I'll go through this a bit faster, but I do want to mention it. So because it's just really easy, we're using the RDF and the SPARQL there. So not entirely our reasoning, but the Neo4j queries that we saw earlier for Reactome, it's that kind of way we automate these things. And I've wrapped that in JUnit. So that we have a nice reporting thing that we'll see in a moment. So I'll keep this on for 5 seconds and then I move on. So this is what it practically looks like, JUnit 4. I'm looking at it, migrating it to JUnit 5 so that we can do more stuff there. This is another example where we do, so where we have the JUnit. So the previous one shows how we integrate in that the loading of the RDF so that we can run the SPARQL on it. We can actually here with this code both use a local, an in-memory RDF source and a SPARQL endpoint, giving us some flexibility of running the same tests on two RDF sources. This is what the thing actually looks like, and being Java code, there's a lot of post-processing that I can do as well, which you'll see on the next slide. This is an example of the SPARQL query, but very often we actually have to combine that. So this one actually uses for anything with an ensemble data source, looking for human pathways, I think. No, we're here actually for you looking for red and filtering out all identifiers that do not have an ensemble red gene identifier. So the post-processing, which is here showing the SPARQL, that is not right. So in the JUnit, yes, because I'm using Java, I can do all sorts of additional things, which, for example, we use for the secondary identifiers, where I have a data set linked to that unit test that will recognize outdated identifiers for Ensemble, HMDB, and Cabby at this moment. Now this is integrated into our continuous integration system. Jenkins we use for that. So the test reports, they get outputted there and then nicely visualized. I don't have to do anything. I'm just reusing there what the open source community provides. And it gives a quick overview of what we have. Now I mentioned something like 60 tests or so. We actually see 600 here. And that's because when I'm running it in memory, it's much faster if I do it in about 9 batches. So all pathways that start with WP1 to WP9, that makes it go a lot faster because of the limited memory allocated on that resource. So we see it runs every test basically 9 times for a subset of the pathways. Then if we look at the output, we actually get something like this. So we see here outdated ensemble identifiers. We see that show up in 6 out of the 9 batches of pathways. And being Java, I can tune the output. So what the output does for most tests is give something that is easy to use for the curators. So it will have a link to the pathway that needs curation, and it has some suggestion of what the curation event should be. So in this case, we have an outdated ensemble identifier where ensemble says it probably is this one. But it explicitly says probably, so indicating there's actually someone that needs to make an expert claim here. Now, I'm a chemist in origin, not an expert in microRNAs, so looking at the identifiers, it just seems a revision, but this is something that really someone that knows, works with microRNA identifiers a lot more should really look at. Now, I'm almost done, so some limitations here is, so what I mentioned earlier, so in the early days, I have a lot of other tests that I'm not running in this frequently run tests, things that create a lot of false positives, for example. So if I look at labels, so one test that I have offline looks at labels that are used for things differently typed. So a label might be GDP or something, which might be used for both a gene and for a metabolite. Now, that's probably not the best example, but I've been looking for labels that are typed with more different things. But these tests actually give so many false positives. I do not want to burden the curation team with that. So those are still outside of those tests. This is something that I might change once I've moved to JUnit 5, where I can tag tests and I can say, okay, this is broad scope curation. So I think closer to the table that we saw earlier, with a lot of curation events, things that we like to improve, but not necessarily pass every day to the curation team. And there are other false positives. So I have some exceptions in things. So one of the tests is proteins don't change to metabolites. Well, that's true most of the cases, but there are exceptions. And bradykinin is an exception there. Insulin is an exception where sometimes you want to encode it as a protein and the other time as a metabolite. And some things that we know, this should actually say unconnected lines. So we have so many of them, and we regularly have tools for that, and we have different actually tests for that reports. But there's so many; those are not things that we at this moment want to run every time, because we will fail. We know it will fail every time. We'll always have unconnected lines. Same for data nodes with identifiers. So don't overload the curators. That is one important bit here. So yeah, with that I sort of also covered the main conclusion. So we can we focus here on regressions, on things that we really affect the data analysis that people do with WikiPathways. So incorrect identifiers means that we can map less experimental data to the pathways, those kind of things. And things that show up more frequently and that we want to fix everywhere. Some outlook is, our reasoning is something that I have been thinking about doing. Now, that in this case is not so appropriate because we use the WikiPathways RDF, which is already normalized. So I would have to do that on the GPML RDF. So that might be an idea. An alternative there is using shape expressions, same kind of thing. So if we have a metabolite data node, this is what we expect to be available for that kind of information. So sort of completeness tests. We have some of that with SPARQL, but not very consistent. So what I mentioned earlier, we don't want to overload. Well, maybe we should start overloading them, but then having two channels of passing that information. And I think it was Ben that asked yesterday, do we have this kind of reports for each pathway separately? That is something that I've been thinking about for a longer time as well, but do not have currently implemented either. So pathway-specific error reports, and then we can actually give all the unconnected lines for that pathway, and I don't know what all the other things that we would love to see curated. The other thing that, so with all the metabolite work now, with all the undefined stereochemistry, all those things that affect the data analysis of metabolomics data, we're going to increasingly curate the chemistry. So I'm not consistently checking for identifiers for salts. That is something that I'll probably work on in the next couple of months. Now, if you're observing things that you see more often, errors that you see more often than you would like to, feel free to put a request here so that I can implement that automated test and make it part of the continuous testing. So there's an invitation to everyone here. So please let us know if there are things that you want to see included here. Thank you very much.
So that, I mean, it sounds like a nice pattern for finding these kinds of errors that we're seeing in other projects as well. So my question is, you know, it seems like you're sort of finding the symptoms but not curing the disease. So like, can you come back to the editor and make it so that many of these errors don't happen in the first place?
Yeah, a very good point. So have this curation actually, or this support of the editors while they're editing. There are some options there in Pathvisio. Maybe Tina will actually mention some of that. In what are you pointing at?
Okay. That topic is something we have discussed, and it would definitely be a significant improvement. Great idea.
It'll be a big topic for tomorrow for development.
Yeah, and that's actually, I mean, since the framework that I have is Java already, converting this to a Pathvisio plugin would actually not be too hard, and complement the things that are already in Pathvisio. Yeah. Thank you.